So today I'm going to present some preliminary results from my project on pain and its comorbidity in older age. At 40 years old, 35 to 40% of the general population would develop chronic pain, and this proportion increases with age with a higher risk for women. Here we can see from the UK Biobank that includes almost 500,000 of participants. Pain was qualified as chronic if it lasted for more than 3 months and included any pain that's interfered with your usual activities, such as headache, stomach or abdominal pain, neck and shoulders, and all of these within the list. So nearly half of the general population is expected to develop chronic pain. So it's important to understand the factors that may amplify this pain-related comorbidity or even represent risk factors. So as we know, physical pain is associated with a variety of physical and mental comorbidities, each of which can contribute to its maintenance or worsening. I derived a psychosocial score of pain-related comorbidity on a large-scale population with an N of almost 400,000. I demonstrated this score can also represent a risk factors for chronic pain on a second visit 10 years later. And finally, I present some preliminary brain imaging results on a subset of these respondents, where I investigate overlapping brain networks between the pain and its comorbidity. So in our pain-related comorbidity score, we use a univariate partial least square, also known as PLS1, to try to explain the number of pain sites from these psychosocial score. What we did is actually we resampled 10,000 alternative distribution with 100,000 participants to sort of obtain standard deviation of these loadings. And we can actually see that they're quite stable. We see that the biggest impact is from neuroticism, so the total neuroticism, and the related items. The most negative loadings were on life satisfaction item. And we can also see that there are potential mediators such as traumas, health behaviors, or sociodemographics still present smaller yet stable loadings. And we can actually see from, for instance, illness and injury and stress from the past 2 years, or health behaviors such as smoking or sleep. And this score had presented good association with the number of pain sites. It correlated about 25% and explained 11% of the variance, which is on such a big population, which is quite good. And then after a 10 years follow-up, what we did is we estimated odds ratio using a simple logistic regression from the participants' score 10 years prior. And after controlling for age and sex, we noticed that being one standard deviation higher than the population made you twice more likely to develop chronic pain, 15% more likely to transit from acute to chronic, and almost 3 times more likely to be prescribed opioids. This was done on their initial score to predict in 10 years later on the second visit. Finally, we present some really quick whole brain analysis, and we use resting state functional connectivity. And we use the slow fluctuation in the bold signal across different brain regions. We also corrected for multiple comparison. And what we did is we assessed the whole brain connectivity across each network, and we saw how each associated with either pain, so the number of pain sites the participant had, its comorbidity from our burden score, or the residuals of pain, so comorbidity free. So we removed the effect of this comorbidity from the number of pain sites. And what we noticed is that across each of these cases, the disconnectivity and the DMN remain strong. And this is interesting because it might actually explains why this DMN disconnectivity can predispose and reinforce the pain when the participant has both a high pain and a high comorbidity. And it's also interesting because we know that DMN disconnectivity is also associated with aging and a large array of psychiatric disorders. So investigating, trying to dissociate the two might actually provide a better understanding of how we understand pain. So pain research has clearly been lacking to the absence of pain phenotype in most large imaging cohort. And the UK Biobank provides a unique opportunity to study chronic pain development and within the context of aging. So I'm very excited for the next year or so to try to pursue this avenue. I would like to thank my supervisor, collaborators, and also the funding of support from HBHL and the Allen Award.